that's fine. I just need to think of a number that can go into both of them. Can you think of a number?
6.
6. 2 works, 3 works, but if you choose 2 or 3, you're going to have to do more work. You always want to try to pick your largest number, but you're not wrong if you pick a smaller one. You just have to do it a couple more times. So you do not have to show this step. This is just for you when you get home.
Are you reducing?
Mm-hmm. That's all I'm doing. Just reducing it. So on top, 18 divided by 6 would give you 3. And 12 divided by 6 would give you 2. And you can leave it as improper. I didn't say it had to be in any kind of specific form. If you change it to mix, that's okay.
It would just be 1 and 1/2.
Mm-hmm. Yes. So let me give you another one. 24 over 36. 24 over 36. Can you think of a number that goes into both of those? 12. You could use 6, you could use 2, you could use 3. You're just going to have to do it several times to get there. 12 is the largest. So I'm going to divide top and bottom by 12. On the top, what would that reduce to? 2. And on the bottom? 3. And that's as far as you can get. So you have a couple like that where you're just finding a number that you can simplify.
And you want to see the 12, 12. You can't
No, I just
hop-
said that. I just said you do not have to show that step. That's just if you need it. Just if you need it. Let me give you a couple of tries. 48 over 60. 35 over 70. Okay, try those two. With number 3, did you pick a number to divide by?
12.
6.
Okay, I heard 12 and I heard 6. Let me show you first with 12, because that is the largest. If you chose 12, on top you're going to get 4, and on the bottom you're going to get 5. And that's as far as you can go. If 48 over 60, this is kind of a cool little trick also. If you chose 6, which is fine, you would have gotten 8 over 10.
You might have to reduce again.
Then what number can go into both of these?
2.
2. And you would get 4 over 5, same answer. And then if your neighbor was like, oh, well, I did it in one step, and you were like, oh, what could I have divided by? Well, look, you divided by a 2 and you divided by a 6. What would you get when you multiply those together?
12.
So it can show you what you should have divided by just to do one step. But if you have to do 2 or 3 steps, that's fine. I've had some people have really large numbers, and they just divide by 2 over and over and over again. That's fine. That's not going to be wrong. With number 4, what'd you choose?
5.
I would put 5. They both end in a 5. So on top, I'm going to have 7, and on bottom, 2. So that's what it's going to look like with the numbers. Just picking the number and keep dividing it until those two numbers don't have anything in common except for 1. All right, now let me give you ones with letters. Again, these you should have seen in chapter 2. Just kind of a review of it. A to the 7th, B to the 5th, over A to the third, B to the second. So if I was to simplify that, where do you have more A's at?
On top,
On top. How many more do you have up there?
4 more.
And remember, you're just subtracting. Where do you have more B's at?
On top,
On top.
3 more.
And you have 3 more. So you've seen this kind. Just simplifying your letters. Sometimes they could end up on the bottom, which we'll see an example here in just a
And
minute.
won't we still have to flip them? Oh, wait, we're not dealing with negatives.
No negatives. No.
Okay.
I don't even have a negative in here.
When you have your positives go on top, negatives go on the bottom. No, no.
No. We're not even dealing with negative exponents.
So the numbers, the higher number goes on top.
Wherever the higher number is, that's where your letter goes. So notice both higher numbers go on top. If I had something like this, C to the 9th, M to the 4th, over C to the 3rd, M to the 12th. Something like that. So where do you have more C's at?
Top.
On the top. How many more do you have when you subtract?
6.
6. But where do you have more M's at?
On the bottom.
So I need to show it's on the bottom. And 12 minus 4, I have 8 more down. Because wherever that bigger number is, that's where that letter goes.
So basically, it's the same rules.
Same rules. Oh, yeah.
So
nothing's
if they're
changed.
both on the bottom, you just got a placeholder of 1 on top.
Mm-hmm. Let's try one more. Let's say we have, we'll throw a number in there just so you all aren't scared. 15, X7, Y9 over, let's try 45, X3, Y7. You write it first. And we couldn't really have these kind of problems in chapter 2 because you didn't know how to reduce fractions yet. So that's why they're kind of integrating it into it now. So the 15 and the 45, let's look at that part first. What number could go into both of those?
Okay.
5. So if I divide the top by 5, what would you get?
3.
3.
You know you can reduce that further once you get the
What
answer.
number?
15.
15. Let's do
Always use the
15.
numbers that are there.
Good. I just want to see if anyone catch it. Okay, so 15 can go into both of them. If you chose 5, that's fine. You just have to reduce it again. The biggest is 15. What would 15 divided by 15 give you? 1. Over. 15 goes into 45 3 times. So we have 1 over 3. All we did was simplified our two numbers. Now we need to look at our letters. Where do you have more X's?
Up top,
Up top. How many more?
4.
4. And where do you have more Y's?
Up top.
Top.
2.
And you got 2.
If you, what I do, I got the same thing, but I divided, like, you know how you use base math, I had to do the exponent, just bring it up, bring it down, and then divide it, and like that. Can you do that? I got the same thing.
You're not the show.
Like,